can make it. No, so like friend.h, that would be like identical to what I have for fractional approach. A couple hours for sure. I didn't spend a lot of time tomorrow.
Okay, guys, welcome back. Here's a look at what's coming up in the near term. You've got your fraction class due tomorrow by midnight. And then, yes?
So in the homework assignment, it says we need friend.cpp and friend.h. Don't you mean fraction.cpp and fraction.h?
Oh, did I write that? Yeah, okay, sorry. Fraction, yes. Yeah, so that's up here.
It's like at the bottom. Well, it says it there, but at the very bottom, maybe it's different.
Thank you.
Like,
yes. Yeah. That doesn't even make sense.
I was like, why would you make
hold on for a second. 167 HTML homework. Probably did that FR and then just finished off with friend.
Yeah.
There we go. Okay. Should be good now. Thank you.
I was just really.
Fraction. All good. The only time that you would submit fraction.h to me is if your above and beyond required you to add something to fraction.h, in which case please do ship it along to me. Any questions about this guy? We're going to talk today, at least for the first half, we're going to talk about this function, add, which is actually hard. You might not think it would be hard, but it is hard when you're adding unsigned integers and you have to keep track of the sign of these things. So we will talk about that, but anything else?
Wait, why can't you add signed integers with add?
I'll talk about it. Anything else technical or otherwise? A couple people were having, Kendall, I think, was having trouble copying and pasting. She copied and pasted. Were you using a Mac, Kendall?
Yeah.
Yeah. So the Mac apparently, in some contexts, will introduce hundreds of illegal, invisible characters. If that's happening to you, you're getting things like, what was that error message?
Like unsigned 302 240.
Yeah, unsigned 302, whatever. Send me an email or the alternative is to look at some of the emails I sent over the weekend. One of them I showed you how to get the file using this wget program to get the file directly, and that should save you from having to copy and paste, which can sometimes be problematic. Any other questions that you're running into? Rebecca?
I don't know if we talked about this, but in main, when you say coot endline, or cout endline, what exactly does that do?
Where are we?
It was, you did it in class last Friday.
When you see out an endline, you're essentially what you're doing is you're saying, I'm done with this line that I'm printing on, so the next characters that come out are going to be on the line below it. And certainly when you're printing your fractions, you don't want to put an end line in your print command. Because if you, as the author of your class, put an end line in your print command, so it prints out the fraction, then prints out the end line, then whoever the user of your class is stuck with that end line. And maybe they don't want an end line after every fraction that they print. And so leave the end line out. Is that possibly clarifying? Okay, other questions? Nice job, baseball team.
Yeah.
Hey, where's Eli?
He is home practicing.
Practicing?
For
Oh, okay. I can deal with that. Anyway, yeah, nice job. Okay. Today we're going to talk about add, then we're going to have a presentation from Lauren, and then I'm going to go on and talk about operator overloads, which is essentially taking your class that you've written, the fraction class, and making it work with just the regular plus sign, the regular multiplication sign, the regular subtraction, regular division, the insertion, the double less than thing, making all of those things understand your fractions. You've already done the hard work. Well, by the time you turn this in, you will have already done the hard work for the next homework assignment, which is to do these what are called operator overloads. So without further ado, let's talk a little bit about adding fractions in your fraction class. Let's go new here. It's today 25. All right. So, a bit of, gosh, I don't know how far back this goes. Maybe 5th grade. Adding fractions. Adding fractions. So if you have two fractions, say a over b plus c over d, without dealing with cancellation or any kind of possible, common denominators or what have you, the simplest way to add these, the formula is just a times d plus b times c over b times d. And this formula will work for any fractions a, b, c, d. And it would be really lovely if you could just take this guy and dump it into your addition function and walk away. But you can't. And the reason for that is, while these fractions a over b, c over d might be negative, your fractions a over b, c over d, they've kind of had their numerator, denominator, and sign kind of all separated from each other. And that's really an annoyance when it comes to adding these things together. So in our case, the numerator and the denominator have been separated from the sign. The numerator and the denominator are positive integers. So let's talk about how we're going to do add. So if a over b and c over d have the same sign, then this isn't too bad. Okay, you can use the formula. So use the formula. So the numerator is just a d plus bc, and the denominator, how do you spell denominator anyway? The denominator is just b times d. And the question is, what's the sign? So now you're writing your addition function. You can safely use the numerator and the denominators from the two fractions, a over b, c over d, and get the new numerator and the new denominator. The question is, what should the sign of that new fraction be? in the case where the signs are the same. Whatever the sign is, right? Whatever the sign was before is what the new sign will be. So the sign is the same as the sign of the incoming fractions. So let's pretend we have two positive fractions coming in. That means that you have a, the numerator is a, the denominator is b, and the sign is false on the first one. The numerator is c, the denominator is d, and the sign is false on the second one. So you take those values, a, b, c, d, you plug them into these formulas, and then the sign is just the sign of the incoming fraction, so still false. Let's assume now, instead of them both being positive, they're both negative. That means the sign is what?
Negative.
The sign variable. True. The sign variable is true. So these guys are going to add the same way as if they were positive, but they were both negative. And so before you leave the addition function, make sure you set the sign of the new fraction to negative. So in the case where the signs are the same, it's not so bad. You can just return. You can return a 3-argument fraction, say a d plus b c b d, and you can just take the sign of either one of them. So let's say this guy is f and this guy is g. We can just take f dot sign. So add is pretty easy in that case. And there should be stars between the A's, the AD, and the BC and the BD, but I didn't bother. Where does this get messy? This gets messy when the signs are different. All right, when the signs are different, you can't use this formula at all, really. When the signs are different, you get cancellation. Ideas? When the signs are different, the denominator is actually still going to be okay, BD. So numerator? There's a problem here, right? Let's look at the numerator as it stands in this formula here, AD plus BC. These are all unsigned integers. If, let's say, f is negative, then what you want to do is, in some sense, you want to subtract. But you have to be careful when you're subtracting unsigned integers. Why? Danielle? I can't actually get a negative number when I subtract unsigned integers. If I have two unsigned integers, say 8 and 10, and I do 8 minus 10, what am I going to get in C++ if I take that and dump it into another unsigned integer? I'm going to get a wraparound. I'm going to get somewhere upwards of 4 billion. Okay? So in order to do this subtraction correctly, I have to actually do some work. What do I have to do in order to subtract correctly? If I have 8 minus 10, let's say I have, let's use some specific numbers here. Let's say we have, I don't know. Let's make A equal 2, D equal 4, B equal, say, 2, and C equal 5. Okay, that's going to give me, and let's say that this is F and this is G. And let's go further and say that F is positive, and let's say that this guy is negative. Now, if we were just going to use the formula, then we would have 8 minus 10 over, what's B times D? 8. And everything would be lovely. But these are unsigned integers, and we've just determined that we can't do 8 minus 10.
Shouldn't it also be A, B, and C?
Sorry?
Shouldn't it be A, B, and then C, D for your fraction? If you're doing
Oh,
fraction.
yeah. So I mixed those up, didn't I? Let's just say F. Sorry about that. F is what? 1, looks like. Or 2 over 2, which is not a legal fraction, but we'll just live with it for now. And G is what? 5 over 4? Thank you. And it's this guy's negative, and this guy's positive. All right. So if we were to do that, could I change A to 1 and still have, yes. Let's change A to 1 so that we're in lowest terms. There. That's actually an honest problem that you could run into. Yes. Yes. Okay, so I know what I want to get out of this. What I want to get out of this is, say, negative 6 over 8, which would then reduce to what, negative 3/4? But I know internally, when I get to that point, 4 minus 10, I've got a problem. How do I get around this?
Could you switch around the order to 10 minus 4 and then throw in the sign manually?
Exactly. So I've got to figure out which of these guys, AD or BC, is bigger, and I have to subtract in the right order. I always have to subtract the smaller guy from the larger guy. So let me give you a summary of how that'll work. So if the signs are different, if AD is bigger than BC, just get this up here. I'm writing this out in a slightly longer way, so I want to keep track of my notes here. So if AD is bigger than BC, then we can subtract. Then AD minus BC is okay, right? Otherwise do what? Yeah, then BC minus AD is okay. That's going to get you the new numerator. And the denominator, no problem. That's the same as it was before. So we're almost there. We've got the numerator and the denominator. The numerator is a little trickier, again, because we have to pay attention to order before we subtract. What's left to do before I'm finished computing this sum? I have to figure out the sign of this thing. So what's the sign of the new fraction?
isn't the sign of A over B and C over D, and which is bigger?
Right. Depends on a lot. Right. So if f is bigger than g, thinking of the two fractions coming in, if f is bigger than g in its magnitude, and f is negative, then what's the sign of the result? Negative or true. And that's the question that you've got to go through for all these possible cases. So let's look at this thing. If f dot sign, so I'm going to be kind of mixing C++ code and just sort of longhand. Oh, come on. So if f sign, so in other words, if f sign is true and AD is bigger than BC, then so if f sign is true, if f sign and AD is bigger than BC, does anybody know how to tell if you have two fractions which one's bigger?
Well, I thought was to use like the decimal function.
Don't do that. Does anybody know how to do it from way back in 5th grade? So we want to ask the question, A over B is bigger than C over D, right? That's what we want to know, is how these guys are related. Let's assume these are all positive fractions, because that's what we're dealing with. Well, I could multiply both sides by D, and that wouldn't change the inequality, whatever it happens to be, right? Because if I multiply both sides of an inequality by a positive number, it doesn't change the inequality. And I could multiply both sides by B, and again, that won't change the inequality, whatever it happens to be.
Couldn't you cross multiply? Yeah.
That's exactly what you end up with. So remember way back in the day when you had to figure out which fraction was bigger, you just cross multiplied, and whichever number was bigger, that was whichever side was bigger, that was the side that the bigger fraction was on. Yeah? So I just kind of put a greater than with a question mark there, but in fact you see that these operations don't affect the equality at all. So no matter what inequality you start out with here, you'll end up with the same one here, working backwards. So the cross-multiplying thing is really the way to tell which fraction is bigger. So if AD is bigger than BC, then F was the bigger fraction, and if F is negative, then the result is negative. Okay, if not F sign and AD bigger than BC, then so now F is positive. If F is positive, what do we know about G? It has to be negative. Why? Because we've already dealt with the case where the signs are the same. So this is only the case where the signs are different. So if F is positive, G is negative. If that condition is true, which fraction was bigger? F was bigger. F is positive. Sign of the result? Positive. Okay. There's a lot of different ways you could do this, but let's just go with if the sign of G is, so if G is negative, and let's go with AD bigger than BC, then. All right, so now G is negative, And AD is greater than BC, which means what? Which one was bigger? That means F was bigger. Then what's the resulting sign? Positive. And last, what do you say? Two big cases. Okay? The first case is where the signs are the same. How do you test whether the signs are the same? Let's go all the way back up here. If the signs are the same, what's a condition here for same sign? You've got these two fractions coming in, F and G. What's a condition for same sign? Yeah, I like that. So that's everything that we talked about with them having the same sign is going to go inside that part of the if statement. The else part of that if statement has all this stuff in it. That's when the signs are different. Like I said, this is not a simple exercise. And you can look at my notes, such as they are, but I would strongly encourage you to actually sit down and try to re-sketch the outline before you do it. I wasn't super careful about the inequalities here. Let's think about, this doesn't account for all possibilities, does it? What's missing? The zero possibility. I can account for the zero possibility by throwing in a less than or equal or a greater than or equal in certain places. Where would be a good place to throw in the greater than or equal on these four statements? What's the sign of zero supposed to be in our classes? In our class? It's supposed to be false, right? Which of these branches is setting the sign to be false?
If not, that's not solid.
Yeah, so let's throw it right here. And that'll take care of zero. And you could probably throw it in right and here as well. If you don't want to think too hard about it, you could just write at the end, check. If you have zero, make sure that the sign is false before you leave. Gosh, don't even want to think about subtraction? Well, let's say we don't want to think about subtraction. What's the best way to do this?
Do it the other way around.
Meh. There's an easier way.
I have a quick question. What do you do in BC is bigger than AD than this one?
Yeah, right. Let me think about this.
Didn't you just repeat?
Yeah, I did. I'm a dummy. Yeah, get rid of this and put this in. My bad. and get rid of this. I don't know what I was thinking, and put this in. Thank you. That would have been there. Yes, thank you. Sorry about that. Subtraction. Given the right pre-existing functions, subtraction is not that bad. Remember that subtraction, if you want to do f minus g, is the same as what? F plus negative g. So you can just do add f what? G dot negation. And there's subtraction. So if you've written your addition function very, very carefully to take care of all this stuff, then subtraction is no work at all. Don't forget to reduce also before you leave these functions. If you're using constructors, however, for example, up here, I used a constructor to return the fraction. If you're using a constructor, reduce is inside that constructor, and so I don't need to do anything. So that'll take care of. So it's highly likely that AD plus BC over BD will not be in lowest terms. But if you feed it into the constructor and then return it, the constructor's got reduce at the bottom, and that'll take care of that for you. Any questions? Okay, Lauren, come on and do your thing. What's your question, Lauren?
I'm doing biometric authentication.
Oh.
Oh, oops. It's not letting me log into Whitmail for some reason.
Joy.
It's redirecting to this page, which doesn't let me into.
Okay, here, let me just get you a new one here, and then I'm going to log out of mine, and we'll see if it lets you. And then go to the Whitman one, yeah. I think all the Google cookies are confusing it.
Cool.
Same way.
There we go. Okay. Okay. So I'm doing biometric authentication, which is basically just like it's the identification of human individuals by their characteristics or traits, like DNA, voice patterns, handprints, behavior patterns, and you'll often see it in movies as like retinal scans or fingerprint scans, but it's a real thing that does exist. So common methods that are in use today, fingerprints, palm or finger vein patterns that can be scanned by a scanner, iris features, or vocal or facial patterns. And actually, blood is another method, like little blood pricks, but it's not commonly used because it's so intrusive and people don't want to get their finger pricked every time that they use. It's often used as a password for like access to certain like it can be used as like a PC password. There are like laptop PCs that come with little fingerprint scanners as a login information, or it's often used for company security and all sorts of things. And there's a lot of pros to its use. You don't ever have to remember your password. It's just part of your body. It's the complex patterns are unique to every human being, so nobody is the same, and it's impossible to lose, obviously. But there are quite a few downfalls also. Oh, sorry. There's some methods are easily replicable, like fingerprint scanning. Like you've probably seen in movies, people wear other people's fingerprints to get into things, and that, like with the current technology, that's still an issue. It's definitely, the scanners can't tell if it's a real finger or a fake finger. Also, it's unchangeable, so if somebody gains access to like your fingerprints or some way of like replicating your DNA or your facial patterns or vocal patterns, you can't change it to lock them out. And also, if something changes, like something about you gets messed up, like cataracts in your eyes is a big issue, or fingerprints getting damaged from some injury, you can be barred from access and not get in. There's also concern for use in unconsented ways, like it can be used to screen for genetic diseases or other undesirable traits. And like facial identification software can be used to like find people when they don't want to be found. And also, kind of a weird thing that I found, there's a serious danger to those with secured items sometimes. In 2005, Malaysian car thieves cut off the finger of a Mercedes-Benz S-Class owner to attempt to steal the car. So there's like that issue with people trying to steal your DNA, whatever, your fingerprints or your, yeah. So it's pretty commonly used in movies, like I mentioned. This is a screenshot from Minority Report, and I was going to show a video, but basically there's the scene where he gets his like eyeballs replaced so that he can't be found by these spider bots that come and like scan your eyes. And there's a lot of like fear. A lot of the movies that like, especially Minority Report, have like this fear of what could happen if biometric authentication like took over our universe and started using, people had to use it to go into every store and go into like pay for things, and that is kind of an interesting problem that's brought up by movies like this, because biometric authentication is becoming more and more prevalent in like society use, and it's becoming more and more developed. There's all these papers online about the future of it and how it's going to be integrated into society in all these ways. And this guy, John Michael McConnell, who is, I'm losing my notes. Okay. He was a former vice admiral in the U.S. Navy, director of U.S. National Intelligence, and he's now a VP of this very prestigious technology consulting firm. And he proposed, basically, in a speech in 2009, to use biometric authentication to log into like tons of all our public networks, and suggesting that potential hackers could theoretically be identified by their traits. But obviously that is an issue with people falsifying information. But there are a lot of private companies and organizations that are beginning to use it as like for like getting into the facilities. The technology is constantly improving and becoming less invasive, like no drawing blood, no forcing your eyes open, more hygienic with no touching, and more accurate and secure. So the constant development suggests that it's going to become more and more prevalent in our society, which is like, it's an interesting problem, and things like Minority Report kind of bring up those issues, but it's also this really amazing kind of technology that could be very, very useful to us. So.
Questions?
like from a, I guess, computer perspective, how does it work to take like, so does it take an image of something, like convert it to digital? Does it?
Yeah, I mean, there's different kinds of technologies for different things, but yeah, basically it's like imaging, like scanning your fingerprints or scanning your iris and like determining like patterns that are only, you know, that are unique to you. And as far as, yeah, I mean, I think that's how it is and is compared to past information. I don't know exactly.
Really, like if you're having a picture, a photograph of someone's iris, and you held that up, like how would they be able to tell that that's the different than like an actual iris?
I don't know exactly, and I'm not sure it's just. I'm not sure if it's just like normal light ray like pictures or if it's some sort of like more in-depth type of scanning. I didn't read that much into it.
How many of you guys have done mass spectroscopy in here? A few people. So that's the identification of a particular substance. I may be speaking wrong. Correct me if I'm wrong. By looking at its spectral frequencies, and you've got spikes in certain areas, and you can match those spikes up. And if you've ever done that, you'll notice that they don't, you know, the things that you get out of the imager are not the same as the thing, you know, you compare the two, and they look about the same, but they're not perfect, not a perfect match. And it's a similar kind of thing here. You know, I'll wipe my thumb on the little fingerprint scanner on my laptop, and something like a Fourier transform goes on, and it generates these frequency graphs, and then it'll match the frequency graphs to the one that's on file, and if they're close enough, then it'll let me in. And the nice thing about using frequencies is then if my thumb goes across like this, or like this, or like this, that rotation, that spatial translation or rotation, it doesn't affect the frequency graph. Like Fourier transforms essentially remove all that spatial information, and all they have left is frequency information. And that way, if I go up to the iris scanner and my head's like this, or my head's like this, or whatever, it's still going to work. Or if I'm a little bit further away or a little bit too close, it's still going to work because it's just looking at frequency information and not spatial information. Is that kind of what you were asking?
Yeah, after the first part, I think this is so clear, like if you had a really good replica of something,
then it's going to let you in.
Yeah. That's one of the biggest issues
Yeah.
that it comes across. Like fingerprint replication is really easy, and I don't know. They didn't talk much about iris scanners, but it's pretty easy to replicate.
Did you get into any of the key logging, keystroke detection stuff?
No.
You can get people to type the same sentence into a computer, and just based on the pacing of how you strike the keys, they can uniquely identify you. And so you can have everybody with the same password, like the quick brown fox jumped over the lazy dog. Everybody types that in, and it'll look at sort of the keystroke timing and so forth, and that's unique, or it's very close to unique. And you do sort of a frequency analysis on that, and then so it's possible that you could have sort of biometric behavioral kind of stuff. Problem with that is if you're trying to get in your computer and you're like 3 sheets to the wind, your typing's probably a little bit different then. But maybe you shouldn't be on the computer in that situation. So, thanks, Marty. Okay. So what I wanted to finish today with, is just a very brief discussion of operator overloads. So what I'd like to be able to do, and I'll just really quickly run through this for you. So remember this example from a while back, my simple complex number class. What I'd like to be able to do in my main program is, instead of, let's do a simpler one, let's do add. So add z and w, I'll print out z plus w, like that. And you'll remember how this guy works. I'll recompile it, and I'll run it. Oops, and I've got my, yes, thank you. So I'll run it, and it says z plus w is 3 plus I5. That works, right? Add the real parts, add the imaginary parts, everything's good. What I'd really like to be able to do, and this is what I'm going to be asking you to do on the next homework, is let that make sense. Because that's how I'd like to be able to do it, not have to worry about this new syntax. I just want to use the existing syntax with my new objects. If I try to do this right now, it says there's no match for operator plus in z plus w, and it talks about possible candidates. But that's the main error. It doesn't know how to add two complex objects. C++ lets you overload the symbol, the plus symbol, so that it can handle your complex or your fractions or whatever objects that you have. Let me really briefly walk you through that, and I'll let you go. The syntax is pretty straightforward. Each operator has kind of a reserved way of talking about it. And what I'll do is first go into complex.h, and I'm going to overload the addition operator. So this will just be a friend, and just like the other guy, so I'm going to add the functionality to this class. I'm going to add the complex number objects to the operator plus. Now I've already done addition, so all I'm really doing is adding a new piece of syntax, allowable syntax. So I've got that guy. Let's go back over to complex.h or complex.cpp. It doesn't really matter that I'm doing this near addition. It could be anywhere. In fact, I'm just going to grab this guy and change the word add to operator plus. Okay, the plus operator takes two arguments. The first thing that you're adding and the second thing that you're adding. And it's going to come in like this, and then what does it do? It does exactly the same thing that add does. So I'm essentially done. I've now made it possible to add things using the plus sign instead of the add function. And it gets even better and even easier for you guys, because once I've written addition, I don't really need to repeat that. I could just do this. And it will use the existing addition function to provide the functionality for the operator overload addition. And everything is lovely. You're going to go through your class and implement addition, subtraction, multiplication, and division, along with a few other things that I've laid out specifically. And we'll talk more about this. We'll talk more about this on Wednesday. But the thing I'll leave you with is it doesn't end with these operators, the normal arithmetic operators. You can also do something like cout x. In other words, you can teach C++ how to print your objects without having to resort to a .print function. Right now, this won't work. Right? It's yelling at me, presumably about the insertion operator somewhere up here. Yes, there's no match for operator, yada, yada, yada. Candidates are blah, blah, blah. We'll talk more about that next time. We're also going to talk about, for example, negation. right? Addition requires 2 arguments. Subtraction requires 2 arguments. Multiplication requires 2 arguments. Negation only requires 1 argument. And we'll talk about this printing out stuff. And certainly by the end of the next class period, you'll be able to rip through homework 7 fairly quickly. And then we'll start talking about the next exam, which is next week. Until then.